Now let us solve some miscellaneous examples based on the formulae related to straight line. In this question we have to find the ratio in which the line x minus y minus 2 equal to 0 divides the join of points 3, minus 1 and 8, 9. Also determine the position of these points with respect to the given line. So now here we are given a line and we are given 2 points. Right? Let's call the points as say A and B. Okay. Right. Now the thing is, if you try to draw the figure, of course not on the graph but just by guessing, then we can immediately sense that there are 2 possibilities. That is, the 2 points can be on 2 opposite sides of a line, or they can be on the same side of the line. Right? So how do we know what is the reality? Right? So for that, what do we do is we assume that they are on opposite sides. So what it means is, let us for the time being assume that the segment joining A and B, okay, it is intersected by the line. Right? So that means if you consider the point of intersection as P, then we will assume that the point P divides segment AB internally in some ratio, and that is the ratio that we have to precisely find out. Right? So let us begin with that. Don't worry about whether it is really internal or external. We will be able to find it out at the end. Now whenever we have to assume the ratio in which this point P divides AB, normally the tendency would be to assume it as m:n, right? But the drawback of this way of assuming is that there are 2 variables involved, that is m and n. That's the 2 unknowns. So rather than that, rather than assuming it as m:n, we assume it in slightly different way. You see, I can write m:n as m upon n as a single quantity divided by 1, isn't it? So this entire quantity m:n, that is m upon n itself, I assume as k, and denominator is still 1. So that means it is sufficient to assume the ratio of division as k:1 rather than m:n. Right? So with that we start off with this question. So here we say that let the point P divide AB internally, so that's the assumption, in ratio k:1. Okay. Now using the formula for internal division, right, the section formula, we can definitely write the coordinates of point P. Right? Now A is 3, minus 1, that is given, and B is 8, 9. Right? So therefore we can write the point P as k into 8 plus 1 into 3 upon k plus 1, comma k into 9 minus 1 into minus 1 upon once again k plus 1. So that corresponds to 8k plus 3 upon k plus 1 and 9k plus 1. Sorry, here it should be plus. So in the final coordinate it should be minus 9k minus 1 upon k plus 1. So you see, we get the coordinates of that dividing point P in terms of the parameter, the unknown k, right? But we have additional condition now. Since we want to find k, we must find one more equation in which k can be substituted. So here we observe that the point P lies on the line given. So that means the coordinates of point P must satisfy the equation of the line, right? So therefore, putting those coordinates, we get, in place of x we write 8k plus 3 upon k plus 1 minus 9k minus 1 upon k plus 1 minus 2 is equal to 0. Correct? So you solve this equation, and at the end we will get the value of k as 2/3. so that I am leaving out. You can easily solve this equation, a very simple equation in one unknown. So now you see the value of k is 2 by 3, and we had assumed the ratio of internal division as k is to 1. So what that means is the ratio of internal division is nothing but 2 is to 3. That's it. Now let us ask the question, that is, in which situation we would have got the ratio as the ratio of the external division. So the simple way to identify that is, if k is positive, that is, if we get the value of k as a positive number, then that is the internal division. So that's a simple way to remember or distinguish what type of division it is. And if k turns out to be a negative number, then it would mean that it is external division. So that is a criterion to test. So if the line is dividing the segment AB internally, then the position of the 2 points with respect to given line means the 2 points are on the opposite sides of the given line. That's the meaning of the second question that they have asked there. Okay. So that's how we solve this particular question. The important takeaway is, whenever you have to find the unknown ratio of division of a segment, you always assume it in the beginning as the ratio to be k is to 1 internally, and then at the end, if k turns out to be positive, then it is really internal division, but if k turns out to be negative, then it means it is the external division. Right? Let's solve one more question. In triangle ABC, A, B and C vertices are given with their coordinates. We have to find the equation of angle bisector of angle A. So let us draw a rough figure. A, B and C. Angle bisector of angle A. So let us show it in yellow color. Of course, although BC seems to be bisected at D, it is not actually bisection. It's not necessarily a bisection, right? So don't assume that D is the midpoint of BC. Okay. I show the symbol for bisection. Right. Now, how to find the equation of angle bisector? You see that we know the coordinates of all the vertices. So we already know the the coordinates of point A. Right. So the only remaining thing is, if by some means we can get the coordinates of point D, then by using 2-point form we can easily find out the equation of angle bisector AD. Right? Now let us ask the question, is there any way to find out the coordinates of point D that meets the opposite side BC? Right? Now this is where we have to recollect one property. Probably you might have studied it in school geometry, that the point D as shown here, right, the point where the angle bisector meets the opposite side, that divides that side in the ratio of the remaining two sides. So what it means is, here in this case, BD is to DC, right? That's the ratio in which segment BC is divided, has to be equal to AB is to AC. Okay, that's the result. That's always true in any triangle for any angle bisector. Okay, so that means we have to get the value of side AB, we have to get the value of side AC, and that's the ratio of internal division. And once we know the ratio of internal division, we can get the coordinates of point D. Okay, so let us calculate side AB. Now side AB is nothing but the distance that we calculate using the distance formula. So that means it is 4 minus 0 the whole square plus 3 minus 0 the whole square. So 4, 3 and 5 form the Pythagorean triad. So clearly 5 is the answer. Similarly AC, here also we calculate using the same distance formula, 4 minus 2 square plus 3 minus 3 square. So clearly the answer is nothing but 2. So that means we get BD is to DC ratio as 5 is to 2. So therefore it is not difficult to calculate the coordinates of point D. Right? Point D will be what? So this ratio turns out to be 5 is to 2. Right? Now point C is 2, 3 and point D is 0, 0. So therefore let us write the formula for D, that is 5 into 0 plus 2 into 0 divided by 5 plus 2, and then you have 5 into 3 plus 2 into 0 upon once again 5 plus 2. So therefore D we get as, on solving and simplifying, 10 by 7 and 15 by 7. So that means we now have got the point D and we already know point A, that is 4, 3. So therefore equation of AD can be obtained by using 2-point form. We know how to write the 2-point form, that is y minus y1 upon y1 minus y2. So whichever way you are comfortable with, you write the equation and then simplify it. X minus 4 upon 4 minus 10 by 7. Okay. So on simplifying you will get the final answer as x minus 3y plus 5 equal to 0. So that's the equation of the angle bisector of angle A.